What's going on, everyone? Welcome back to the Techie. I'm Elliot, and today we're going to be building a Kubernetes cluster on Proxmox. Now, some of you might be asking, Elliot, why are you doing this? We follow you on LinkedIn. We know you got a lot of projects going. Well, that's partly why I'm doing this. I do have a lot of projects that are hosted on GitHub right now, and I'll post that in the description so everybody will have access to that. But I've got two main projects that I want to kind of bring together. The first, like I said, if you've been following me, is you know about my network automation platform, and it's an observability platform built with Claude Code in mind. And the new project that I'm working on is an AI agent that can troubleshoot networks the way that a senior network engineer would be able to, and be able to think and reason within your network and within a cured set of documents. So I'm wanting to find a way to host all those projects in one place and allow them to basically work together on some infrastructure that is enterprise grade. So my vision is that the brain does the thinking and the network ops platform kind of like gives you hands that'll allow you to execute things on the network. So like I said, they just both need some, a real platform to run on, not my laptop. They need things like persistent storage, secrets management, and network access, to my lab devices. So I'm building this cluster, and as you see here, you can take a look at this environment and the layout and my stack and what I'm using here. And I just wanted to let you guys know that this is phase one of this build. We're going to go from a bare Proxmox server to a 3-node K3s host, cluster with Cilium, MetalLB, and NGINX Ingress. So come along. We got a lot of videos coming along in the future. We're going to deploy some real workloads. So let's get into it and get building. All right, now before we begin, a couple of things to note, a few prerequisites. I'm on a Mac Mini, so that's my main machine here. In order to get this going, I needed to SSH my key pair on my Mac Mini, so that involved me generating a key first. If you don't have one, you'll need to generate an SSH key, and then I had to copy that my public key over to Proxmox, and I did that through SCP. Like I said, the instructions are going to be in the guide that'll be in the descriptions, or you can go to my website and download it. But and also make sure you have all the Kubernetes stuff installed already on your Mac. It'll just make everything go simple. So anyway, prerequisites good to go. So out of the way, so let's go ahead and, like I said, let's get to building. The first thing I'm going to do is we're going to SSH into my Proxmox box. So we'll say SSH into root at your IP address. Whoops. And that is going to be there we go. Okay, so now we need to download our image. I'm going to download an Ubuntu 24.04 cloud image. So I'm going to say cd, we're going to change directory and go to our /var lib vz/template /iso. Okay, and we're going to do wget h cloud images .ubuntu.com/noble/current/noble server cloud image amd64.img. All right, give that a second to download. I'll probably pause the video here while it takes a few seconds. All right, we're back and we've got our image downloaded. So next thing we need to do is create our template VM. So we're going to say qm create 9000 -name It's going to be Ubuntu Cloud template. Okay, the memory is going to be 2 gigs. We're going to go with 2 cores and net 0. All right. Is going to be RTO, and bridge is going to equal vmember 0. All right. Now the next thing we want to do is import the cloud image as a boot disk. Okay, so we'll say qm import disk 9000. We'll say /var lib vz template ISO noble server cloud image md64.img local LVM. All right, this doesn't take as long. All right, great, done. It's clear here. All right, so the next thing that we want to do is we want to configure the template. So we'll say qm set 9000 dash SCSI HW. So that's going to be virtuo CSI piece. Virtuo psi PCI, and then dash SCSI 0. Say local LVM is going to be VM dash 9000 dash disk 0. All right, and qm set 9000 IDE 2 local LVM is going to be cloud knit. All right, so we've got that there. And so now we're going to do our boots. qm set 9000 dash boot. The order is going to be SI 0. Yep. Okay, so we got our boot order there. So now we need to set our display. So we go qm set 9000 dash serial socket dash VGA serial 0. And nope, not socket, socket. Oh, that's serial 0. There we go. All right, now qm set 9000, and we'll say dash as agent enabled equals 1. And I think I messed that up as well. Yes, not sir. Set. Okay. Now let's go ahead and set up our cloud init. So I'm going to show you this command, but I'm going to pause it because I have to put in my password and all that good stuff. So first thing we're going to do here is we're going to say cat and then SSH / IID RSA.pub. And we're going to send it in temp. And all right, we're going to pause here. Okay, so I've entered in my password. So what we've been doing, like I said, is we entered in a command to basically combine the SSH keys from Proxmox to my Mac Mini. I went ahead and created my username, which is my name, and my password. Now I'm going to continue setting up my cloud init attributes. So we're going to say qm set 9000. We're going to do our SSH keys. And they're in temp, all keys, .pub, I believe. Yes, okay, and that's fine. You can see that. That's your public key there. So next is going to be qm set 9000. We're going to say our name server. It's going to be Google and search domain is lab.local. All right, now we have to convert this to a template. So I'm going to say qm template 9000. All right, so there you see it's renamed it, and the volume on the disk has changed. So next we're going to start working on our nodes here. So the first thing we're going to do is clone the nodes. So I'm going to come in and say qn clone 9000 and 101. This is going to be our main node here. So give me just a second here. All right. So it's a 9101 -- name. It's going to be K3S server and full. All right, and these take just a few seconds to clone. And like I said, we're doing 3 of these here. We're going to do our main, and then we're going to do 2 workers. Okay, that one's done. So we're now going to say, we're just going to come in and say qm clone 9000 102 -- name. That's going to be K3S worker 01 -- full. All right, and the final one, so we're gonna, let's just come up here. It's gonna be worker 2, and it's gonna be 103 here. All right, so all 3 nodes have been cloned. So let's go ahead and clear the screen. Next, we need to size each node, okay? So each, well, let's just start with my server. It's gonna have 4 CPUs, 8 gigs of RAM, and a 50 gigabyte hard drive. So we're gonna say qm set 101, since we named it 101 -- so we're gonna give it 4 cores. We're gonna say memory. It's going to be 8 gigs. We're going to say, yeah, let's do that there. All right, and then we'll resize the hard drive. So let's say qm resize 101 SCSI 0, and we'll say 50G. All right, so it's successfully resized. Now let's go ahead and do worker 1. Now the workers are going to get 8 virtual CPUs, 32 gigabytes of RAM, and 100 gigabyte hard drive. So we're going to go qm set 102 -- cores is going to be 8, and the memory is 32768. All right, and then we'll say qm resize 102 SCSI 0, and we'll say 100G. All right, and now number 3, so qm set 103 -- cores is going to be 8 -- memory is 32768, and the resize, qm resize 102 103 SCSI 0, let's say 100 key. Okay. Now we need to assign our static IPs, okay? So this is going to be for each node. We need to assign it in a static IP because we don't want it to change, and then we're also going to assign it a gateway. So we're going to say qm set 101 -- IP config 0. We're going to say IP equals 192.168.168.101/24. And the gateway is going to equal 192.168.68.1. All right. And so we'll say qm set 102 -- IP config. The reason I like doing this is it just helps you build muscle memory typing it, helps you get faster, and it helps lock in what you're seeing. At least it does for me. If I see it and do it, it's just easy for me to remember and recall later. If something goes wrong, I'm able to visualize it. So that's just a little tip on my end there. All right, and then the third one, config 0, so IP equals 192.168.103/24, and gateway equals 192.168.168.1. All right. Uh-oh, what did we do wrong here? qm set 103 IP -IP canary. Hold on. Okay. So next, let's start our VM. So we'll say qm start 101. This is our main. All right. And next, qm start. And let's just do it this way. qm start 102 and 103. And let's clear. All right, so let's test if we can SSH into 101. So again, we're on my Proxmox server now at .76. Let's see if we can SSH into our Kubernetes host main server here at 101. So I'm gonna say SSH. I went ahead and gave it, created a username Elliot at 192.168.168.101. Oh, okay, let's see. There we go. All right, and let's now see. There we go. Just had to clear, because I've done this before. So clear the SSH keys. It'll take a little minute. I'll probably need to go ahead and do it for clear those keys for 102 and 103 as well. So once 101 is added here, we'll go and do that for the other two, and then we'll just test that connectivity is good. So I'm glad I showed this on camera. So bear with me for a moment. I'll pause it and come right back. Oh, never mind. We don't have to. All right, so let's clear. We are in 101, as you can see here. We have changed. So let's exit out. I need to go in and clear these for 102 and 103. If you don't know, like I said, I'm clearing the SSH keys because I permanently assigned them earlier. So it's a conflict when I try to read SSH into them. You can Google how it works and what we're doing, but this is the easy way for me to get around it. So let's go ahead and just make sure SSH into 102 and 103. Oops, 192, let's see. All right, .168.102. Yes. All right, and clear, we'll exit out there. And we'll SSH into 103, yes. Great. So we are able to SSH into all of our nodes. They are all good and up and running. So let's go back into 101 and we will update. So we'll say sudo apt update. And sudo apt upgrade -y. And then we're going to install curl. So sudo apt install -y curl open iscsi iscsi. I always have trouble with that one. And then NFS common. All right, so everything's upgraded, all of our dependencies are installed. So now, yeah, got all our prerequisites done. Now I'm going to install K3s. So bear with me. I'm just going to copy a command and paste it because it's a pretty long command. So we're going to curl this there. And like I said, again, all of this is in the description for I'm going to leave the document. So you'll have that there. Right, great. So K3s is installed. Let's clear here. All right, so the next thing that we want to do is we want to check our node status. Now, it'll probably show that it's not ready because the CNI isn't installed, but at least I don't think so. But let's check. So we'll say sudo K3s kubectl get nodes. Sudo. There we go. So it's not ready. So I'm going to pause here while I copy my tokens over. So just bear with me and I'll be right back. Okay, we're back. Yeah, I had to pause there, like I said, because I needed to get my join token and you don't want that out there. So I went ahead and got that, copied it somewhere. I'm good to go. So the next commands we're going to do is we're going to set up our kube config for non-root use. So the first thing we're going to do here is going to make this directory in here. Now I've already done this, so I'm just going to kind of go through the commands of what I did. The next thing we're going to copy the YAML file to the file that we just created. We're going to change the owner. Okay, let's do this here. Let me just make sure. I might have missed one, so I'm going to run through it again. So we're going to say sudo copy /etc rancher k3s.yaml say .cube/config. Okay, we're going to change the ownership to sudo -u there $$ ID G. Okay, now we're going to export it. And let's say make sure echo export Okay. Now we're going to install the prerequisites on each of the workers, and we're going to join the workers now. So we're going to install the prerequisites on them and join them to the cluster. Then I'm going to replace the token that's on them with the token that I got from step 3. So that's why, like I said, you need to save that and keep it. So we'll do this here. I'm going to, type all until we get up to the part where I have to do this. So let's go ahead and exit out of node 1 or 101. So now we'll SSH to worker 1. Okay, let's clear here. So let's go ahead and update sudo apt update egress and typing is horrible today. There we go. All right, so now let's sudo apt install -y. So say curl open SISCSI and NFS common. Told you, there we go. All right, so now I'm going to put you on a pause, and I'm going to go ahead and finish all of this because both workers are the same. So when we come back, we'll come back to verifying that the clusters are up. All right, we're back, and now let's verify that the clusters are working. So let's go ahead and SSH back into our server. And we will go kubectl get nodes. Now, they should not, I was gonna say they should not appear ready, but this is still good news. Our basically cluster is up. The server with the 2 workers are showing they're not ready yet, but they're up and they're running. So good step here. So next thing we're gonna do is we're gonna install Cilium. So we're going to install Cilium as the CNI for the full kube proxy replacement via eBPF. Okay, so I'm not going to go into the details of all that and what that means. The video is already long enough, but we're going to run these on the server node. And the first thing that we're going to do is we're going to run a curl command. So we're going to say curl -fssl, and I'm just going to copy and paste the IP address. Or the URL, sorry. Let's make sure here. Yep. There we go. It's always SL. You know what? Okay, let's do it this way. It's always one letter. There we go. And I'm going to do a lot of copy and paste on this to install Cilium, but let me get you first going. Let's go hem. Yeah, let's type it out. Hem, so repo add Cilium, and it's from https://hem.cilium.io. Okay, so hem repo update. All right, good deal. Now we'll say helm install Cilium /Cilium. And now we're going to add all our parameters here. And this is where I'm going to copy and paste. Like I said, you can either screenshot or, again, This will be in the description where you can get this there. All right. So all that, yes. All right, good deal. Now let's verify. So let's see here. So let's exit out here. You know what? Actually, let me go back in. And then I'll say cube CTL get nodes. All right. Let's see, it might take a while. Okay, that's what we were waiting for. We were waiting for the server to transition. So it's ready. Okay. Now let's go cube ctl-n. We'll say cube-system get pods -l. So say app.kubernetes.io/part of equals Cilium. All right. So next, let's clear, and we'll install MetalLB, okay? So we're gonna deploy it in layer 2 mode with an IP pool on the home subnet. And to get that downloaded, the first thing we're gonna do is say helm repo. Okay, so add MetalLB and the URL. GitHub.io/MetalLB. All right, it's been added. So now we'll do helm repo update. Alrighty, and helm install MetalLB, MetalLB, MetalLB. And like I said, this is where, let's see. Hold on a minute. There we go. All right, so it might take a while for all our pods to be ready, but we'll say cube ctl, all right, -n MetalLB -system wait dash is going to wait for condition to be ready, and on the pod for all pods, and timeout is going to equal 90 seconds. All right, condition met on all of our pods here. All right, now great. Next, we want to configure the IP pool and the layer 2 advertisement. Now, this is another long one, so I'm going to just copy and paste here. All right. Okay, so I got away from myself. I tried to copy and paste it. It didn't take because of the error got thrown off, so we'll just type it here. So cat elf just bear with me. All right, we're back. So had, like I said, some troubles with that whole copy and pasting thing, but we finally got it set up. We're good. Next thing, almost done, guys, is to install NGINX, the Ingress controller. So we're going to install it or deploy NGINX and verify that the MetalLB assigns an external IP address like it's supposed to. So let's come here, and so we'll say helm repo. We'll say add ingress dash nginx from HTTP, and that'll be Kubernetes .github.io / ingress nginx. All right, been added there, so we'll do helm repo update, and we'll say helm install ingress dash nginx and ingress nginx and ingress nginx. Namespace is ingress nginx. Let's say dash dash create namespace, and we'll set controller service external traffic policy equals local. All right. Now it's clear, and let's verify that we got an external IP address. So we'll say kubectl -n ingress nginx get service, and we got an it's pending. So give it a moment here. We're looking for this value here. It could take a moment. Let's pause here. All right, guys, we're back, and we've got the external IP address. So we know we're good there. All right. Next thing we want to do, so we can go ahead and exit out here because we're going to do this from our main terminal here. So not even our Proxmox box. So from my main terminal, I'm going to say make directory, and we're going to go to .cube. All right, already exists. I'm just showing you how we would do this, guys. The next thing I would SCP from, so I'm going to SCP from my K3s server, so 192.168.168.101, and the file is going to be in cube.config, and we're going to cube/config. Okay, and see, I've already done this, but let's just show you how you, again, so SSH keygen -r, and this is 192.168.168.101. SSH-keygen. All right, let's try that again. Say yes. There we go. We've got the file copied over. And so next thing we need to do is fix the server address, because K3s defaults to your local host, the 127.0.0.1 address. So I'm just going to do sed -i ::s -127.0.0.1 -192.168.168.101 / there, and we'll move that to kube/config. Okay. And now we're going to validate end to end. So let's do one last clear. And we'll say kubectl nodes-o wide. Let's get nodes, Elliot. And there we go. We have all 3 nodes up and ready. Let's see if we can make that a little bit neater. I don't know if we can, but as you can see, all 3 of our nodes are good. All have, you can see their internal IPs, their images, and their versions, and they are ready on their status. So next thing let's do is check all of our pods here. So we'll go kubectl. We'll say git pods -a. Every pod now is showing running. Great. Next thing we want to do is let's go ahead and test the MetalLB and NGINX path from our Mac Mini here. So we'll go curl -v http :// so 192.168. We're set 200. It should return a 404 good down here. That's the name. That means basically that the full path is working. So we are done, guys. We basically have our Mac Mini to our LAN, to our MetalLB VIP, to our NGINX Ingress pod. This cube or this cluster is now up and running, and it's ready for us to continue. The next step for me is going to do some Longhorn storage. Then I'm going to deploy ChromaDB and the engine or the brain for the engineer brain, so that agent. So I know it's been a long video, but if you follow this, follow the guide, you'll have your own Kubernetes cluster up and running on Proxmox. So I hope you were able to take something from this video, and I'll catch you in the next one. Have a good one.